When students reach the stage of data analysis in their research projects, one of the most confusing questions they often face is this: how do we determine whether two variables in a study are actually related? For example, if a researcher studies social media usage and academic performance, an important question arises. Does spending more time on social media affect students' academic performance, or are these two things completely unrelated? In research, we cannot rely on assumptions or personal opinions to answer such questions. Instead, we use statistical techniques that help us examine relationships between variables in a systematic and scientific way. Three of the most important techniques used for this purpose are correlation analysis, regression analysis, and hypothesis testing. These tools help researchers answer critical questions such as: is there a relationship between two variables? How strong is that relationship? Can one variable predict another? Is the relationship statistically significant? In today's episode of Research Hub and Academic Mentorship, we will carefully explore these three important statistical tools and explain them in a way that students can clearly understand and apply in their research projects. Understanding variables in relationships analysis. Before discussing correlation and regression, we must first understand the concept of variables. A variable is simply a measurable characteristic that can change or vary among individuals or situations. Examples include age, gender, study hours, academic performance, social media usage. In many research studies, variables can be grouped into two categories: independent variables and dependent variables. The dependent variable is the factor believed to influence another variable. The dependent variable is the outcome or result being studied. For example, in a study titled "Impact of Social Media Usage on Academic Performance Among Undergraduate Students," the variables will be: for independent variable, it is social media usage, and for dependent variable, it is academic performance. Researchers want to know whether changes in the independent variable influence the dependent variable. This is where correlation and regression analysis become useful. Now, let's understand what correlation analysis is. Correlation analysis examines whether two variables are related and how strong that relationship is. For example, suppose a researcher collects data from students on number of hours spent on social media, their academic performance scores. Correlation analysis helps determine whether students who spend more hours on social media tend to perform better, worse, or about the same academically. The result of correlation analysis is called a correlation coefficient, usually represented by the symbol R. The value of R ranges from -1 to +1, that is, -1 to +1. Let us interpret this value. If, for instance, R equal to +1, it means here that there is a perfect positive relationship. This means that as one variable increases, the other variable also increases. But if R equal to -1, it indicates a perfect negative relationship. This means that as one variable increases, the other variable decreases. If R is equal to 0, it means no relationship exists between the variables. In real research studies, correlation values often fall somewhere between these extremes. For example, R equal to 0.65 indicates a moderately strong positive relationship, while R equal to -0.40 indicates a moderate negative relationship. SPSS can calculate these correlation values automatically once the data has been entered. Now let's understand how to interpret correlation results. When researchers obtain correlation results from SPSS, they must interpret them carefully. Two important aspects must be considered, and they are direction of relationship and strength of relationship. Direction tells us whether the relationship is positive or negative. Strength tells us how strong the relationship is. For example, a correlation value of 0.70 suggests a strong positive relationship. This means that as one variable increases, the other variable also tends to increase. However, it is important to remember something very critical in research. Correlation does not necessarily imply causation. This means that even if two variables are related, it does not automatically mean that one variable causes the other. That is why researchers must interpret correlation finding carefully. Now we move to discussing regression analysis. While correlation tells us whether two variables are related, regression analysis goes a step further. Regression helps the researchers determine how well one variable can predict another variable. In regression analysis, the independent variable is used to predict the dependent variable. For example, a researcher may want to know, can social media usage predict academic performance among students? Regression analysis provides an equation that estimates how changes in the independent variable affect the dependent variable. This allows researchers to make predictions based on the data collected. Regression is therefore widely used in fields such as economics, education, business research, and psychology. SPSS can generate regression tables that show the strength of prediction, statistical significance, and regression coefficients. These results help researchers understand how meaningful the relationship between variables actually is. We move on to discussing hypothesis testing. In many academic research projects, researchers formulate hypotheses. A hypothesis, like I mentioned in the previous episode, is a testable statement predicting the relationship between variables. For example, there is no significant relationship between social media usage and academic performance. This type of statement is called the null hypothesis. Researchers then collect data and use statistical tests to determine whether the null hypothesis should be accepted or rejected. SPSS helps perform these statistical tests quickly. If the statistical result shows that the probability value, often called p-value, is less than 0.05, the null hypothesis is rejected. This means the relationship between variables is statistically significant. If the p-value is greater than 0.05, the null hypothesis is accepted, meaning the relationship is not statistically significant. Presenting correlation and regression results in Chapter 4 is also very important, and we need to talk about it. After performing statistical analysis, researchers must present their results clearly in Chapter 4 of the research project. This usually involves presenting correlation tables, regression tables, and interpretation of findings. For example, a researcher may write, "The correlation analysis revealed a moderate negative relationship between social media usage and academic performance." It's usually represented, the formula is usually represented as follows. You open bracket R equal to minus 0.45. Then you have your P less than 0.05. Then you close your bracket. This statement communicates the strength, direction, and significance of the relationship. I want you to know that clear interpretation helps readers understand the meaning of the results. Understanding statistical relationships between variables is one of the most powerful aspects of research analysis. Tools such as correlation analysis, regression analysis, and hypothesis testing help researchers move beyond assumptions and examine evidence objectively. When these techniques are applied correctly, they allow researchers to discover meaningful patterns and relationships within their data. Friends, in the next episode of Research Hub and Academic Mentorship, we will move to the final stage of academic writing. We will explore Chapter 5, where researchers present the summary of findings, draw conclusions, and make recommendations based on the results of their study. Mastering this final chapter helps transform research findings into useful knowledge that can guide decision-making and future research. Thanks for staying with us. Kindly subscribe to this YouTube channel for more educational insight, and please share with others. Thanks once again, and see you in our next episode. Bye for now.